We're gonna find out what goodies are inside of there. See if there's anything in there I can reuse and what I can recycle. Alright, next we may as well open it up. Take out some stuff. I wonder if I can do anything with this. Rolls right out. Now, how does the door come off? Alright, we're going to release these springs. It's a pretty fancy setup. It's a sound deadening blanket. Now we've got the control wires here for the soap dispenser. This is a soap dispenser door. So when this activates, it trips open the door. Like that. Here we have a closer look at that mechanism. You can see this is your soap dispenser door here. So you would put your soap in there and close the door. And then when it's time for the soap to be released, they send power to this mechanism, which pushes out on this lever and pops the door open. See if we can pry it out without damaging it. Alright, it is ELTEC, LTEC. And let's see here, it's got some information, 120 or 240 volt. Here I've got my handy dandy testing cord. All we do is plug this end into the wall, and we'll find out what happens when you send 110 volts to this. Alright. 1, 2, 3. Absolutely nothing. I'm guessing that this actually isn't a servo or electromagnet type thing. I'm guessing that there's probably a bimetal strip or a heater in here that causes it to activate slowly. Alright, I've got this open. All we have is this fairly strong spring, which is a return spring. We've got the plunger, we've got the two contacts, and I believe I was somewhat right. I'll explain this in a second here. This is very interesting because I believe this is the same basic plunger that they use in a Honda gasoline engine automatic choke. So what is happening here is they put power to one side of this and power to this resistor on the other side, and so the electricity flows into this and heats up the body. And if you look at the center pin there, that pin actually protrudes or sticks out. Alright, so what I'm going to do now is I'm going to plug the other end of this cord into the wall and basically do a time lapse. We'll see how quickly that plunger comes out. Alright, that was less than a minute. Let's see, on the timer we have 1 minute and 16 seconds. I'll take my infrared thermostat, point it at the bench. It is about 15 degrees. And when we point it at this thing, 25 degrees through the case. So we'll take this apart and see how hot the wax thing actually is. See, 46, 50, so it's over 50 degrees. I ended up breaking mine apart, but if you ever have to replace this vent or whatever this thing is at the top, this ring turns off. The ring locks in. You have to turn the outside piece counterclockwise, and then it pops apart. If it's a few years old, you probably won't get it apart without breaking it anyway, because a lot of crud gets jammed in around there. I quickly broke apart the piece that I broke off the top there, and it has the exact, well, not exact, it has a different colored plunger, but the same deal. It has a resistor on the side of it, and the body of this is filled with wax, and when you heat the wax up, it expands and it pushes the pin out. Here is the circuit board on this MAYTAG, and as AVE would say, it looks pretty skookum. If you look at the circuit board itself, it's all covered in this, yeah, I don't know what it is, silicone or celastic. It's rubbery, Yeah, it definitely, it looks like silicone. And the same thing on the back. The whole circuit board has been dipped in this silicone stuff, which has done a very good job of protecting it from moisture. Got the motor for the pump. We've got a motor for the drain. And then we've got some valves and a heater coil that attaches here. We'll just start taking this stuff off and see what it's all about. So what we have here is the water feed valve, and the water from your house hooks up here, and when power goes through this, it allows the water to go in through this hose and into the side of the dishwasher right here. The drain pump has a bunch of silicone around it, which I don't think that would be factory. I think that probably aftermarket. Somebody added that on there because it was leaking. This O-ring here is what's supposed to seal it, and apparently it wasn't doing a good enough job, so there was some silicone added to the outside of it. Seems to be an awful lot of penetrations around the bottom. It makes me weary about it leaking. This is EMZ 39.0412.17. This looks to be some sort of sensor that when something passes through here, it detects it. So I'm going to take my multimeter and test this thing, whatever it is, and see if we can determine what it is by an ohm reading. So if it's a safety override, it will simply be open or closed, and if it's a sensor, it will have a specific ohm reading. So this is some sort of limit switch. So basically, if it gets too hot, yeah, that's what it is too. If we see the placement of it, the heater ring goes around like this, around the outside, from this end around and right past here to this end. So this is touching against there, and if it gets too hot, it breaks this circuit, shuts it down so that you don't melt a bunch of stuff inside of your dishwasher. 1/3 horsepower, 120 volts, 60 hertz. Thermally protected. Okay then. That's quite the gasket there. I'm going to take a wild guess that this is an expensive piece. Got a mechanical seal here. Yeah, this piece would be expensive. Got a ceramic mechanical seal there. So that stainless steel ring presses against that ceramic ring and seals it. Same as they use in an automotive water pump. So I'm not sure how old this thing was, but it appears to be in very good condition and appears to have very good build quality. Now that I've taken this dishwasher apart, I'm thinking that I would have been better off to use this as my dishwasher and get rid of my dishwasher. This one is quite well built. There was nothing really wrong with it. It could have used a couple of seals or O-rings replaced, but yeah, I really like the build quality of it. A couple of things that surprised me about this: it actually uses a cutter to cut stuff up if it gets debris into the bottom. So if you get food scraps and stuff in through the screen, it chops it up before it sends it through the pump. So that was pretty neat. There's a lot of stainless steel parts, which is nice to see. Everything kind of snaps and fits together, and if you know what you're doing, you would have no problem taking it apart without breaking pieces. I was also surprised by these wax plunger things, or actuators. Yeah, I've never seen them before in electronics, but they're probably quite commonly used. I just don't usually work on this stuff. Somebody can correct me if I'm wrong, but I'm going to take a wild guess and say that this is a water level sensor for the drainage. So this sits down into the bottom of the sump, and I'm guessing what its job is to indicate or to trigger the pump to turn off once the sump is empty. There's not much left to this. We've got a couple sliders and some metal frames. I'm going to take this stuff off, throw all my scrap metal in the scrap metal bin, and then we'll be done with it. This is what the dishwasher looked like before, and this is what it looks like now. I hope you guys enjoyed watching, and I will see you next time.